We've got the gradient of a line perpendicular to line A, line B, and line C. Okay, we are just required to find the gradient of a line that is perpendicular to line A. So we have to find the gradient of line A. So to do that, we are going to find 2 points that lie on the line. Let's take this point here, 6, 3. Call that point P. And we'll take this point over here, 4, 2. Call that point Q. Okay, so the gradient of PQ, line A, is given by y2 minus y1 over x2 minus x1. So it's going to be 2 minus 3 over 4 minus 6. That's minus 1 over minus 2. So the gradient of PQ equals positive a half, no decimals. Gradient must be written as a fraction. Now we want the gradient of a line, any line that's perpendicular to PQ. So the gradient, let's call it gradient of line 2. We don't care what we call it. The gradient of the perpendicular line will be the negative reciprocal of a half. So because the gradient of PQ is positive, the perpendicular gradient is negative, the reciprocal of a half is 2 over 1, which is just 2. The gradient of perpendicular lines, gradient 1 times gradient 2. Perpendicular lines have got their respective gradients, the product of their respective gradients being negative 1. This is the condition for perpendicular lines. So a half times minus 2 equals negative 1. So the quick way is just to take the negative reciprocal of a gradient when you're working with perpendicular lines. A line B, we want to find the gradient of a line perpendicular to line B. So let's just take a point on B. Let's take this point over here. Call that M. So M will be the point 3 minus 2. Let's use Q again. Q lies on line B, which is 4, 2. So the gradient of MQ is y2 minus y1 over x2 minus x1. So it's going to be 2 minus minus 2, 2 minus, and use brackets, 2 minus minus 2 over 4 minus 3, 2 plus 2, minus minus 2 is plus 2, so 2 plus 2 is 4, over 4 minus 3 is 1, so the gradient of MQ equals 4. The gradient of the next line, line 2, the line that is perpendicular to line B, the gradient will be the negative reciprocal of 4. 4 is positive, so the perpendicular gradient will be negative, and the reciprocal of 4 is a quarter, because 4 equals 4 over 1. 4 times minus a quarter equals minus 1, and that's the condition for perpendicular lines. Gradient 1 times gradient 2 equals negative 1. Line C, use point Q again, and let's use this point here. We call that T. So T is going to be the point 1, 4. Q we're going to use again because it lies on that line. Q is 4, 2. The gradient of TQ is y2 minus y1 over x2 minus x1. So 2 minus 4 over 4 minus 1 equals minus 2 over 3. So the gradient of TQ is minus 2 over 3. Therefore, the gradient of the perpendicular line, it doesn't matter that we keep on calling it line 2, they're different problems each time. The gradient of the gradient of line 2 that's perpendicular to line C or line TQ, the gradient of the second line will be the negative reciprocal of minus 2/3. So the negative of a negative is positive. We don't have to write the positive in. And the reciprocal of 2/3 is 3 over 2. So the gradient of the second line is 3 over 2. Again, we are not writing this as 1.5 or 1.5. We are leaving it as fractions. Okay, question 2. We're given two lines, y equals 2 plus 5x and 5y plus x equals 6. We're required to show that the lines are perpendicular. In order to show that the lines are perpendicular, we need to show that gradient 1, the gradient of the first line, times gradient 2, the gradient of the second line, equals negative 1. This is the condition to show that lines are perpendicular. So the first thing we're going to do is take each of these lines and put them into standard form. They're not in standard form. So the first line in standard form is y equals 5x plus 2. All we did is rearrange the terms, but this is in the form y equals mx plus c. This is how we want the line to be written. 5y plus x equals 6. This is not in standard form, so 5y equals minus x plus 6. Then we divide every term by 5. So y equals minus a fifth x plus 6 over 5. This is how we leave the line. No decimals whatsoever. Okay, so gradient 1 is 5. Gradient 2 is minus a fifth. Okay, now we're going to say that gradient 1 times gradient 2 equals 5 times minus a fifth, and 5 times minus a fifth equals negative 1. So now we can say, therefore, line 1 is perpendicular to line 2. So we'll call that line 1, and we'll call this line 2. So because the product of the gradients is negative 1, the lines are therefore perpendicular to each other. Question 3. Work out the gradient of a line perpendicular to each of these lines. Okay, so the first line is y equals 3x. So for perpendicular lines, gradient 1 times gradient 2 must be negative 1. So gradient 1 is 3. Okay, that's the gradient of the first line. Now we want the gradient of a line that is perpendicular to this. They're not asking for the equation of the perpendicular line. They just want to know what its gradient is. So we're just going to say, therefore, gradient 2 is the negative reciprocal of 3. So it will be minus 1 over 3. That's all we need to do. B, y equals a half x minus 15. Gradient 1 equals a half. The line must be in standard form in order to read off the gradient. Therefore, the second gradient, the gradient of the perpendicular line, will be the negative reciprocal of a half. So that's positive half, so the perpendicular gradient is minus, and the reciprocal of 1 over 2 is 2 over 1, just minus 2. Y equals, in standard form, that's minus 0.4x plus 3.5. Now, just as I said, no decimals. Here we come across examples that have got decimals. Okay, if you're given decimals, we've got to deal with it. But generally speaking, we do not work with decimals. Okay, gradient 1 is minus 0.4. Therefore, the gradient of the perpendicular line, gradient 2, will be the negative reciprocal of minus 0.4. Now, 0.4, so it's going to be positive. We're not going to write the positive in. This is minus 4 over 10, right? So the reciprocal of 4 over 10 is 10 over 4. And 10 over 4 equals 5 over 2. We do not write this as 2.5 or 2.5. Leave it as a fraction. Okay, again, we've got decimals here. Which is annoying to say the least. Okay, 7.5 is 15 over 2. And that'll be 57 over 10. The gradient 1 is 15 over 2. Therefore, gradient 2 is the negative reciprocal of 15 over 2, be minus 2 over 15. Question 4. Very similar, find the gradient of a line perpendicular to each of these lines. So before we do anything, the line must be in standard form. So y equals minus x minus 5. The gradient of this line is -1. Therefore, the second gradient will be the negative reciprocal of -1, which is +1. Y equals y plus a half x equals 4. This is not in standard form, so y equals minus a half x plus 4. The gradient of this line is minus a half, so the gradient of the perpendicular line will be the negative reciprocal of minus a half, which is +2. Again, this line is not in standard form, so we put it into standard form. 4y equals minus 3x plus 5. Divide through by 4, y equals minus 3/4 x plus 5/4. The gradient of this line is minus 3/4. Therefore, the gradient of the perpendicular line will be the negative reciprocal of minus 3/4, which is 4/3. D, 12y minus 2x equals 15. Again, this is not in standard form. 12y equals 2x plus 15. Divide through by 12. Y equals 2x over 12 plus 15/12. So in simplified form, y equals a sixth times x plus 5/4. The gradient of the line is 1/6, so the gradient of the perpendicular line will be minus 6, the negative reciprocal of 1/6. Question 5. Find the equation of the line that's perpendicular to y equals 5x and passes through each of these 3 points. Okay, the origin is the point 0, 0. The equation of the line that we have is y equals 5x. We'll call this line 1. We want the equation of a line perpendicular to line 1 and it passes through the origin. So line 2, y equals mx plus c. The gradient of line 1 is 5. The gradient of line 2, which is perpendicular to line 1, will be the negative reciprocal of 5. So it will be minus a fifth. So y equals minus a fifth x plus c. And now we substitute the point 0, 0. X is 0, y is 0. So 0 equals minus 1/5 times 0 plus c. So c equals 0. So line 2 has equation y equals minus a fifth x. B. Okay, line 1 is the line has equation y equals 5x. Line 2, y equals mx plus c. The gradient of line 1 is 5. Line 2, the second line is perpendicular to the first line, which means that the second gradient, the gradient of line 2 is the negative reciprocal of 5. So it's minus a fifth. The point 0, 10 lies on line 2. So x is 0 and y is 10. So 10 equals minus a fifth times 0 plus c. 10 equals 0 plus c, so c equals 10. Therefore, line 2 is y equals minus a fifth x plus 10. And c, line 1 is the line y equals 5x. Line 2 is the line y equals mx plus c. Line 1 has got a gradient of 5. Line 2 has got a gradient that is the negative reciprocal of 5 because line 1 and line 2 are perpendicular to each other. So the second gradient is minus a fifth. The point 10, 0 lies on line 2. X is 10 and y equals 0. So 0 equals minus a fifth times 10 plus c. 0 equals minus 2 plus c. C equals 2. Line 2 therefore has equation y equals minus a fifth x plus 2. Question 6. Find the equation of the line perpendicular to 5x plus 3y equals 30 and passes through the point minus 20 minus 10. Okay, so the line, let's call this line 1, is 5x plus 3y equals 30. Now, before we even consider line 2 is going to be perpendicular to line 1. We are going to get line 1 into standard form. So 3y equals minus 5x plus 30. We divide through by 3, y equals minus 5/3 x plus 10. This is line 1 in standard form now. The gradient of line 1 is minus 5/3. That means okay, the line 2 is y equals mx plus c. We know that the gradient of the second line of line 2 is the negative reciprocal of minus 5/3 because line 1 and line 2 are perpendicular to each other. So the negative reciprocal of minus 5/3 is 3/5. So y equals 3/5x plus c. Line 2 passes through the point minus 20, 10. So x is minus 20, that's minus 10. So minus 10 equals 3/5 times minus 20 plus c. Minus 10 equals minus 60/5 is minus 12 plus c. C equals 2. So line 2 has the equation y equals 3/5 x plus 2. Question 8. A is the point minus 4, 5. B is the point 6, 7. The perpendicular bisector of AB is a line perpendicular to AB and passes through the midpoint. We're required to find the equation of the perpendicular bisector of AB. Okay, with all coordinate geometry, we're going to be drawing a diagram, right? Do not attempt any coordinate geometry problem without first drawing a diagram. Okay, A is the point minus 4, 5, minus 4, 5. So that's where A is. B is the point 6, 7. 6, 7 is there. Okay, we are required to find the equation of the perpendicular bisector of AB. Okay, perpendicular means cuts at 90 degrees, right? And bisector means cuts in half. So we're looking for a line that cuts AB at 90 degrees, but it also cuts AB in half. That means we need to find the midpoint of AB, and we'll call that M. The perpendicular bisector of AB is a straight line passing through the midpoint of AB, so passing through M, but that line is also perpendicular to AB, so it cuts AB at 90 degrees. Now, just by looking at the diagram, that looks like it's the midpoint. Again, this is not what maths is about. It's not about what it looks like. This is just an estimate until we've actually worked out, until we've solved the problem. We are just going to be drawing in a sketch to help us, to assist us in solving the problem. We'll call this, if M is the midpoint of AB, then let's just call this line, put a point on the line and call it T. So MT will be the perpendicular bisector of AB. So basically, MT will cut AB at 90 degrees, and M will be the midpoint of AB, so that means that AM will equal MB. That's what it looks like as a diagram, something like that. Okay, so we draw the diagram so we know how to solve the problem. So the first thing we're going to do is find the midpoint of AB. Okay, before we get there, how do we know the equation of a straight line is y equals mx plus c? We need to know the gradient and one point that lies on the line. Now, on the blue line, the perpendicular bisector of AB, we'll get the gradient from the gradient of AB. Because MT is perpendicular to AB, gradient 1 times gradient 2 equals -1. We can easily find the gradient of AB, which means we can find the gradient of MT. So that'll give us the gradient. Now the point that lies on MT will be the point M, because the point M is the midpoint of AB. So that's where we'll get the point from, and we've got everything we need to find the equation of MT. Okay, so let's start with the midpoint of AB. The midpoint of AB is x2 plus x1 over 2, y2 plus y1 over 2. So A is the point, -4, 5. B is the point, 6, 7. So the midpoint of AB will be 6 plus -4 divided by 2, and then 7 plus 5 divided by 2. 6 minus 4 is 2. 2 divided by 2 is 1. 7 plus 5 is 12. Divided by 2 equals 6. So M is the point, 1, 6. Now that just happens to be the point that was sketched. That's because the diagram was drawn accurately. But if it's not, if you haven't sketched the diagram accurately, then it will not look like the answer that we got, right? It might look slightly different. Again, if you sketch something accurately, you'll get an accurate answer. So we've got the point M. So we've got the point that we need. Now we need to know the gradient of MT. Okay, so to find the gradient of MT, we're going to use the fact that the gradient of MT times the gradient of AB equals -1. We know this because we are looking for the perpendicular bisector of AB. So the perpendicular bisector of AB will be the line MT. So MT is perpendicular to AB. So if we can get the gradient of AB, then we'll know what the gradient of MT is. So the gradient of AB is y2 minus y1 over x2 minus x1, which is 7 minus 5 over 6 minus -4. That's going to be 2 over 10, which is a fifth. So therefore, the gradient of MT, MT being perpendicular to AB, will be the negative reciprocal of a fifth. So the gradient of MT will be -5. And now that we have a point that lies on MT, we have the gradient of MT, we can now determine the equation of MT. So y equals mx plus c. X is 1 and y is 6. So 6 equals m is -5. -5 times 1 plus c. 6 equals -5 plus c. C equals 11. So y equals -5x plus 11. And this is the equation of MT, the perpendicular bisector of AB.